Hey guys, welcome back everybody. Hope you all are doing great. Guys, this is a user demand video. One of my paid student shared this topology with me and requested me to configure it from scratch, from the zero. So today I am going to configure this topology from zero. We'll also discuss about this topology, like this type of network is suitable for which type of company, correct, right? Then why I have connectivity from two different ISP for, you can say, load balancing, or to configure primary and secondary. So I can configure this security device as a firewall in such a way so that it will perform load balancing. So it will forward some traffic to ISP1, some traffic to ISP2, or I can configure ASA firewall in such a way so that it should forward all traffic towards ISP1 if ISP1 is up, right? So my primary ISP is ISP1. So until and unless ISP1 is up, then users should be reachable to internet through ISP1. But if ISP1 is down, then automatically ASA should shift the traffic towards ISP2. So these are depends on configuration. Okay. So I have one ASA firewall for security. Then I have one core router, guys, for internal routing. Like I have lots of end devices and lots of departments are there. So I'm going to perform segmentation for each department, right? Means I'm going to divide large network into a smaller network. So I need a device for internal routing. So that's why I'm using this router here for internal routing. Then I have two distribution layer switch 1 and distribution layer switch 2 for, you can say, distributing and aggregating the traffic. And why I have two devices, guys? So that I can achieve load balancing at distribution layer, or I can configure again active and standby scenario. Like if my switch 1 is up, then it should be active, otherwise switch 2 should be active. So for the backup also, it is going to help me to achieve redundancy as well. It is going to help me to achieve load balancing as well. Like for some VLANs I want to forward traffic towards switch 1, and for some VLANs I want to forward traffic towards switch number 2, means through switch number 2. So I can configure the scenario, right? So that's why I have two device here, and it is good for scalability as well. Let's say in future if I need to add one more core layer switch, I can add here easily. Then I have lots of access layer switches for end devices, right? So on access devices I am going to separate each department with the help of VLAN, right? Then guys, I need to configure link between switches as trunk so that it will carry traffic of all VLANs, because here we have lots of VLAN. You can see VLAN number 10, that is data VLAN, right, for data traffic. VLAN 20 is voice VLAN for voice traffic. Even you can configure priority. You can give priority to voice traffic. So you can configure your router or ASA firewall to provide quality of service. Then we have VLAN 30, that is server VLAN. So we have some servers in VLAN 30. Then VLAN 40, let's suppose this is HR VLAN, right? So these are department, guys, and let's suppose in each department I have 200 users. Okay, so this network can be implemented in one building as well, right? This network design can be one, branch office of a large enterprise company, or this design can be a network of a small company, right? Single network where employees and HRs, or let's say server voice traffic, should be able to access network resources as well as internet. And like this I can have another branch as well somewhere. Okay, so how you are going to configure this topology, right? How you are going to configure this type of topology from the scratch? Whatever protocols is required, whatever features I need to enable over here to secure my network, to make reachability, I'm going to configure, implement it today in this video. Like, see, from the scratch. And users, some users are in HR department. So HR peoples don't know how to configure IP addresses on the machine. So you need to set up the DHCP server. Actually you need to set up DHCP for all VLAN. So you need to create multiple DHCP pool. Either you can configure DHCP on core switch 1 or on core switch 2, or on both for the backup. So let's suppose on both switch I'm going to enable DHCP, or I can place one DHCP server somewhere, right? So we are going to enable DHCP service on any devices so that all end devices can get IP address from DHCP. Like here I can have some wireless devices as well, which is connected with AP access point, right, wirelessly. So these devices also need IP address from DHCP server. So I'm going to set up DHCP server. Then guys, we can have some IoT device, Internet of Things devices. Those devices also need IP address from DHCP server. So first of all, we will implement DHCP here, right? Then we need to configure switch port, like access layer switch ports and distribution layer switches port, right? So here these ports should be trunk, this port should be layer 3, these ports should be access and layer 2, right? And these ports should be placed in a appropriate VLAN, in a correct VLAN. So we need to configure VLAN also. So DHCP, then switch port configuration, then DHCP, sorry, DHCP is already done, then VLAN, then we are going to configure, let's say, port security for end users, right? I can configure port security on access layer switches. So let's say port security, right? Then guys, we need to configure access layer switches, means their MAC address table, what should be the aging time. According to our requirement, we are going to decide aging time for each VLAN. Let's say I want to define more aging time for HR's user, because generally HR users are forwarding traffic to switch. So I will increase the MAC aging time. So we need to configure MAC address table here, MAC address table as per real time requirement. Then we can configure DTP protocol for dynamic trunking, right? So link between switches should be configured as trunk. So I can configure DTP protocol, or I can manually configure trunk both side, right? So DTP, or let's say VTP for VLAN propagation. It totally depends on you, that you want to create all VLAN on all switches, or you want to configure it on one switch and want to propagate to all other. So you can configure the VTP, right? And you can ignore it as well. Then to avoid loop between switches here, between access layer and distribution layer, we can configure RSTP protocol, which is fast spanning tree protocol, right, to avoid layer 2 loop. Then I can enable port fast on access ports, so that access ports can up immediately, can come in forwarding state quickly. So port fast is also required. Then to access all these devices from a centralized location, we can configure telnet and SSH on all device. We can enable telnet and SSH. Then we can enable password, or I can configure the console password, line VTY password to secure these devices. Then we can configure the description on links, like this link is connected with distribution layer switch 1, right? After that, I need to configure default gateway on, let's say, core layer switch. Even you can use this router as a default gateway or distribution layer switch, but it will be better if I will use distribution layer switch as default gateway, so that we can perform routing between router 1 and router 2 for better performance, right? So for better performance, I am going to create SVI on distribution layer switch. So SVI configuration is also required, SVI for multiple VLANs. Then layer 3 port, this port and this port, I need to make these two port as layer 3 port, and after that I need to configure IPs there. Then to achieve, let's say, redundancy between distribution layer switch 1 and distribution layer switch 2, I can configure HSRP here, HSRP or VRRP or GLBP between distribution layer switch 1 and distribution layer switch 2, right? Even I can achieve load balancing. I can configure lower priority on switch number 2 for, let's say, VLAN 20 and VLAN 30, and I can configure more priority on switch number 2 for VLAN 10 and 40. Right, so this is how I can achieve load balancing as well. Or I can configure switch number 1 as active switch and switch number 2 as a standby switch. So if switch number 2 will goes down, then switch 2 will become active. Otherwise, all traffic will go through switch 1. So I can configure HSRP. HSRP is also required here. Then guys, to exchange prefixes between distribution layer and core layer, as here we have SVI, right? So we need to exchange route between distribution layer and core layer. Not only core layer, even distribution layer to ASA firewall. In this area, we need to perform routing. So I can configure routing protocol. Let's say routing protocol is OSPF, because generally in real time also we are using OSPF. Then you need to configure the router, IP addresses on router, and after that you need to enable OSPF. You can configure the authentication here. You can configure the ACL for VLANs, right? You can configure policies. Even you can configure NAT here, right? Then you need to configure ASA firewall. On ASA firewall, again I need to configure NAT. I need to configure default route towards both ISP, toward ISP1 and ISP2. So as I have two ISP here. Okay, so I am going to implement these all protocols today in this video. Right now, guys, if you want to know more about this network, here you can see this network design. And first of all, for which type of company this network is suitable? Let's say this network is suitable in one building of a university. Let's say in a university there are 4 building, guys, right? There are 4 building, and this is building number 1, let's say main building. So this can be network designed for the main building, and like this I can implement same network in other building also. After that I can connect all building together at core layer. Means my core layer router is connected with another building. Again at another building, means at each building I have one core layer device, so I can connect all buildings together at core layer. Even I can connect at distribution layer as well, but again for better performance we will connect all building together with core layer switch, right? Or it can be a network of a small company where you have around 500 or 600 employees. You have some servers, one server room, 20 to 25 servers are there. So for those companies also this network is perfect. Definitely here I can add one more ASA device, right, for redundancy between ASA and router. I have redundancy at distribution layer, but I don't have redundancy at core layer. If this link will goes down, that means these users are not reachable to internet now. Yes, I have 2 ISP, means backup, but here is the problem. End users cannot access internet if link between ASA firewall and core router will goes down, or ASA firewall goes down, or router will goes down. So here we need redundancy so we can improve this network, right? Or I can have connectivity from a single route ISP also. That can be also one scenario, right? So this network is generally common design, right, for real time, guys. So if you know the configuration of this network, then that means you can configure almost 80 to 90% network in other design also, because this is common one where I am going to use NAT. The only thing is I am not going to configure IPsec and VPN here to make communication between 2 private network. Let's say like this, I have one another branch somewhere, okay, and both are connected with each other. Then how to configure IPsec there, right? First to create a tunnel between 2 private network, then how to secure it, right? Otherwise everything is here, right, in this network. And configuration can be different according to the configuration. I can use this topology in for multiple purposes, right? Like if I want to achieve load balancing at distribution layer, I can configure the topology. That depends on configuration. If I want to configure active passive at distribution layer, I can configure the topology in such a way so that it will work like active and passive. If I want to achieve load balancing between ISP1 and ISP2, I can configure the ASA. If I want to configure primary and secondary ISP, I can configure the ASA. Okay, so configuration can be different. Configuration can be different to achieve different tasks. My task is first make reachability between all end devices to ASA firewall, then configure ASA firewall to access internet. Okay, so without wasting our time, let's begin. See guys, this network is here. I have internet connectivity, 2 ISP for redundancy, and ASA firewall providing security and possibly load balancing between the ISPs. Then I have one core layer device. This is all about ISP. Core layer router, which is connected with my firewall and managing internal network traffic. So core layer is managing all internal traffic. As I told you, I will subnet the network, So core layer is the device who is going to make reachability between all networks. Then guys, distribution layer. At distribution layer, I have two switch 1 and switch 2 connected to core layer. Router providing distribution and aggregation of traffic to access layer switch. Right? So why we have two devices at distribution layer? For, you can say, redundancy. And distribution layer is doing what? It is distributing the traffic, right, between multiple access layer switches. And when access layer switches are generating traffic for internet, that time distribution layer is aggregating the traffic and it is forwarding to core layer, right? So distribution layer is responsible for distribution and aggregation of the traffic. Then guys, access layer switch. So I have 4 access layer switch where n devices are connected, and I am using VLAN for segmentation, right? So the design can support multiple VLAN for different departments. VLANs can be configured on the distribution layer and access layer switches to segment the network logically. So this is how we are going to configure the topology. Now guys, let me access the devices. First of all, I am going to configure ISP1 because I will not have access to ISP router later. So let me do one thing. Let me configure IP addresses on both ISP and let me close the console of ISP. So ISP1 enable config T and say hostname ISP1 and interface F0/0, say no sut, and IP address. The public network which I am running between ASA and ISP1 is 1.1.1.0/29, right? So IP address over here is 1.1.6, last IP address from this subnet. Because I have some servers as well, so I need to configure a static net, means bidirectional net. That's why we have multiple public IP address. Okay, so submit mask 255.255.248 because slash value is 29. Done. Then I need to create one loopback here, loopback 1, where I'm going to define IP 8.8.8. 8.8.8 subnet mask, let's say 255.255.255.255. You can assume that this is one server on internet. Done. ISP1 configuration is done. Let me write the configuration, and I can put one more thing here. I can put one description on fast Ethernet 0/0, like description connected to let's say XYZ network. XYZ network, right? So this interface is connected with, let's say, XYZ network, or it can be ANT network, AT&T, or it can be Airtel, it can be Tata, right? Done. ISP1 configuration is done. Let me write the configuration and let me close the console. Then guys, go to ISP2 and let me configure ISP2 also. This is ISP router, host name ISP2, interface F0/0, say description no sut, description connected to XYZ network. Done. Then I didn't configure IP here, 0/0. So IP address subnet between ASA and ISP2 is 2.2.2.0/29, and here IP address is .6, again last IP address, and 248. Then I need to create one loopback, so say interface loopback 1 and IP address 255.255.255. This is server on internet router, exit. Done. Now guys, ISP configuration is done. Now let me configure my private network. So what I told you, first of all, I need IP addresses on client machines, right? First of all, I need to configure IP addresses on client machines. So I am going to set up DHCP here, but you know, DHCP for multiple VLAN. So as I have multiple VLAN and we have different segment for each VLAN, you can see I have already performed subnetting. I have already divided the large network. Maybe my large network is 192.168.0.0/16. right? So after the submitting, this is my submit for VLAN 10, this is my submit for VLAN 20, this is my submit for VLAN 30, and this is my submit for VLAN 40. Okay, and you need to create SVI for all VLAN guys on both switch, on distribution layer switch 1 and distribution layer switch 2. So first of all, you have to decide one IP address for distribution layer switch 1, one IP address for distribution layer switch 2. That is going to be default gateway for each VLAN, right? So let's suppose for VLAN 10, default gateway is going to be, let's suppose from this submit 192.168.1 dot, let's say last IP address 254 on switch number 1. This is on switch 1, distribution layer switch 1. Then for VLAN 20, let's say 192.168.2.254/24. For VLAN 30, let's suppose my subnet is 192.168.3.254/24. And after that for VLAN 40, let's suppose 192.168.4.254/24. So I'm going to configure these IP addresses on distribution layer switch 1, and on distribution layer switch 2, second last IP address 253. Wait a minute. Yes, 253, and on this also 253, here also 253, second last IP address, and here also 253. Done. So default gateway for end users is clear for all VLANs. Now guys, I need to exclude these two IP addresses from DHCP pool for each VLAN, right? For each department, you can say. Department is in front of you. VLAN 10 is data VLAN, VLAN 20 is voice VLAN, VLAN 30 is server VLAN, and VLAN 40 is HR VLAN. Done. So we need to exclude these IP addresses from DHCP server. So let's suppose I'm going to create one pool of DHCP for VLAN 10, means for data VLAN, where network is going to be 192.168.1.0/24. Default IP address is going to be this IP address, right? No. Default gateway IP address will be virtual IP address, because you are going to configure HSRP here. HSRP, that means you are going to define virtual IP addresses to client machine. So let's suppose my virtual IP address is 192.168.1.100, means .100 from each VLAN. That is my virtual IP address. So that will be default gateway. So default gateway IP address is going to be 192.168.1.100, and I need to exclude two IP addresses. So let me do this. Let me set up the DHCP on let's say core layer switch 1. So let me access core layer switch 1, and here I am going to first configure IP addresses. Config T, and say interface VLAN 10. By the way, first of all, VLAN is not there in VLAN database, so I can configure the VLAN, and I am configuring it like real time. So I will configure the VLAN name also. So VLAN 10 name is going to be data VLAN. After that, VLAN 20 name is going to be voice VLAN. VLAN 30 is server VLAN, so I can say server VLAN. Then VLAN 40. VLAN 40 is guys HR VLAN. So name HR underscore VLAN. Done. So now you can verify the VLAN. Do so VLAN brief. So I have configured 4 VLANs here. By default VLAN is VLAN 1. And guys, these all VLANs are active VLAN, data VLAN, voice VLAN, server VLAN and HR VLAN. Status of all VLANs are active, but we don't have any ports in these VLAN. Now I am going to configure SVI here. So interface VLAN 10, IP address 192.168. What IP address here I have decided for this VLAN on switch number 1.254, 1.254, subnet mask 255.255.255.0. IP address 255.255 192.168.1.254, sorry. Done. And then say no set. After that exit interface VLAN 20. For VLAN 20 also I need to do same thing, say no set and IP address 192.168.2.254 255.255.255.0. Then go to VLAN 30 interface and say no set and IP address 192.168.3.254.255.255.0. After that interface VLAN 40, say again no set and IP address 192.168.4.255.255.255.0. Done. Say no set. Now if you will check, so IP interface brief, so you can see I have IP addresses on all VLANs, in all VLANs interface. But guys, right now these interfaces are down, their status is also down and their line protocol is also down, right? But VLAN status are up. So VLAN brief, so VLANs are up, you can see status is active but their interfaces are down. The reason is there is no any interface in VLAN 10, 20, 30, 40. There is no any interface in these VLAN, you can see, right? As well as we don't have any trunk link over here. So that means there is no one member of any VLAN. There is no any interfaces or member of this VLAN. So either I can configure trunk here, right? So trunk is the member of all VLAN, means there is one port in VLAN 10 also, VLAN 20 also, VLAN 30 also and VLAN 40 also, because by default trunk port is the port which is member of all VLAN, means it can carry traffic of all VLAN. Then you can remove the VLAN from the trunk link, you can add the VLAN on trunk link. Definitely we will add only these 4 VLAN on the trunk link and one more VLAN for management, that is VLAN 100, right? So for now these ports are up, but don't worry about these port. Once I will configure the trunk link, these ports will come up. Then go to core number switch 2 and let me create SVI here on core switch 2. Enable config T VLAN 10 name data VLAN, VLAN 20 name, VLAN 20 is voice VLAN, then VLAN 30 server VLAN, VLAN 40 HR VLAN. Now I need to create SVI. I have created the VLAN, right? So go to interface VLAN 10, say no set first and IP address, second IP address of subnet, right? For VLAN 10 you can see 192.168.1.253, so 192.168.1.253 255.255.255.0. Exit interface VLAN 20 and say IP address 192.168.2.253 255.255.255.0. 0 and no set. Exit. Interface VLAN 30 and IP address 192.168.3.253 255.255.255.0. Exit. Interface VLAN 40 no set and IP address 192.168.4.253 255.255.255.0. Right. So VLAN brief. So I have these all VLAN. Right. Or guys, I can configure VTP as well to propagate the VLAN information. Like I can configure VLAN on distribution switch 1 and then I will enable VTP protocol, but link should be trunk. So you have to configure trunk first. Now show IP interface brief. So again here also you can see these port status are down and line protocols are also down, but VLAN 30 is administratively down, means I need to run no set command here. Interface VLAN 30 no set. Right. Now save the configuration. On distribution switch 1 also I can save the configuration. Right. So I have set up the DHCP. No, I have configured the SVI and VLANs on distribution layer switch. Now I am going to set up the DHCP. So let me take you to distribution switch 1 and let me create one IP DHCP pool. IP DHCP pool and for let's say VLAN 10. So VLAN underscore 10, where I am going to define network 192.168.1.0, submit mask 255.255.255.0 and default router as I told you virtual IP address 192.168.1.100. Let me write the virtual IP as well here. Virtual IP 192.168.1.100 for VLAN 10. Done. Now again let me take you to distribution layer switch and see default gateway IP address is correct. Then I can define DNS server IP, let's say 8.8.8. Then exit. I need to exclude two IP address from this pool. So say IP DHCP exclude address 192.168.1.254 as well as 253. Right. So I have excluded two address. Now let me create pool for VLAN 20. So IP DHCP pool VLAN 20. So network will be 192.168.2.0, subnet mask 255.255.255.0 and default router is going to be 192.168.2.100. virtual IP address for VLAN 20. Then guys DNS server IP address, let's say 8.8.8 and exit. IP DHCP exclude address 192.168.2.253 as well as 254. Then IP DHCP pool for VLAN 30, pool VLAN 30, network 192.168.3.0, subnet mask 255.255.255.0. right. Default router 192.168.3.100, correct. And then DNS server IP 8.8.8. exit. IP DHCP exclude address 192.168.3.254 and 253. Then I need to create pool for last VLAN, that is VLAN 40. So IP DHCP pool VLAN 40, where network is going to be 192.168.4.0 255.255.255.0, default router 192.168.4.100, right. And DNS server IP 8.8.8. exit. IP DHCP exclude address 192.168.4.254 and 253. So I have set up the DHCP guys on distribution layer switch 1 and I can set host name D1, right. Let me write the configuration, save the configuration, then go to switch number 2, and on switch number 2 also I am going to set host name. Right now what I need to do, and on the distribution layer switch guys, I need to configure these link, right? So link between switches should be trunk, so that access layer switch can forward traffic to distribution layer switch. So let me do one thing, let me configure DTP protocol on distribution layer switch. So let me take you to distribution layer switch 1 and say interface range E0/0 3, right? All ports 0/0 to 3 means all 4 ports. Interface range is 0/0 to 3, right? So these all ports should be trunk. So say either you can say switch port trunk encapsulation. So you can define the encapsulation protocol here. Encapsulation protocol can be .1q or SSH, and as you know we will use .1q for better security, for better performance. Nowadays we are using only .1q, even Cisco is also using .1q. So I have defined the encapsulation protocol. Now I'm going to say switch port mode dynamic desirable, means this port is dynamic, these ports are dynamic desirable. By default switch port is auto, dynamic auto. So auto cannot form trunking, but auto and desirable can form trunking. We'll do same thing on distribution layer switch 2 also. Interface range E0/0 to 3, right? And say switch port trunk encapsulation .1q and switch port mode dynamic desirable. Now here we can verify the trunk link guys on distribution layer switch 1, let's say. So interface trunk. So yes, I have some trunk link here. You can see 0/0, 0/1, 0/2, 0/3. These ports are trunk port, right? And now if you will check IP addresses on interface, so IP interface brief, you can see your VLAN means SVI interfaces are now up, and their line protocols are also up, because I have trunk link here, right? And trunk link is part of all VLAN. So again, if I will remove VLAN 10 from the trunk, then the status and their protocol is going to be down, right? So how many trunk interfaces here I have? 4. And guys, on all trunk link we need to allow only 4 VLANs, right? By default all VLANs are allowed, means if I will create VLAN 50 here, let's say VLAN 50 and exit. So you can see, so interface trunk. So on the trunk link guys, VLANs allowed and active in the management domain, means it is able to forward traffic, is 50 also. But for the security purpose you need to remove VLAN 50 from the trunk link, because this trunk link is going to carry traffic of this department only, right? Data VLAN, voice VLAN, server VLAN and HR, that's it. So I am going to remove VLAN 50, go to again interface range E0/0 to 3, and now I can say what? Switch port trunk allowed VLAN 10, 20, 30, 40, that's it, right? Now again if you will check, so interface trunk, you can see now VLAN 50 is not allowed on the trunk link, right? So we need to do same thing on distribution layer switch 2 also guys. On distribution layer switch 2 also you can run this command, so interface trunk. So you can see I have 4 trunk link here, and all VLANs are member of that VLAN, of those trunk link. So see, all VLANs are allowed over here, 124094. So I need to allow only VLAN 10, 20, 30, 40. And here also you will verify, if you will verify the SVI interface, so you can see your SVI interfaces are up, their status are also up, line protocols are also up, right? So IP route. So you can see these switches have install network ID in their routing table as well, right? So just go to go to these interfaces, interface range E0/0 to 3, and say switch port trunk allowed VLAN 10, 20, 30, and 40, right? Now again, so interface trunk. So you can see this time on the trunk link, VLAN allowed on the trunk link 10, 20, 30, 40 only, correct? Encapsulation protocol is .1q. Their mode is desirable, and mode on access layer switches are auto. So auto and desirable can form trunking, and all distribution layer switches are going to negotiate encapsulation protocol also, and it will set .1q. So go to any distribution layer switch, sorry, access layer switch, and you can verify it. Let me take you to access layer switch 1. Here also I can configure a host name, switch 1. Then here you can verify the trunk, so interface trunk. So yes, you can see 0/0 and 0/3. 0/1 is connected with distribution switch 1, and 0/3 is connected with distribution layer switch 2, and both link are trunk link, guys. Both link are trunk link, and allowed VLAN is again all VLAN are allowed here. And how it have formed the trunking? Their mode is auto. Encapsulation protocol is .1q with the help of negotiation, and the status is trunking. Native VLAN is VLAN 1. For the security purpose, you need to change native VLAN as well. So on this switch, what I can do, guys, interface range E0/0 and E0/3. E0/0 and E0/3. What I can do, I can set different native VLAN. Then again you have to set native VLAN on switch number, distribution switches as well. Before that, let me do one thing. Let me allow only 10, 20, 30, 40 VLAN. So switch port trunk allowed VLAN 10, 20, 30, and 40, right? Then I can say switch port trunk native VLAN. Native VLAN is, let's say, VLAN 100, and let me do it on distribution layer switch as well, otherwise you will get native VLAN mismatch error. So interface range command is here, and I am going to say switch port trunk native VLAN is VLAN 100. See the log message for native VLAN mismatch. On the distribution layer switch 2 also, this is the range command, and say switch port trunk native VLAN 100. Now native VLAN is matching, but on access layer switch 2, again native VLAN is VLAN 1. On access layer switch 1, now native VLAN is VLAN 100. So interface trunk native VLAN is 100, and allowed VLAN is 10, 20, 30, 40 only. Okay, now guys, I need to configure access port. So see, on switch number 1, we have how many user? PC1 and PC2, and PC1 and PC2 is member of which VLAN? PC1 is member of VLAN 10. That means I need to put this interface in VLAN 10, and VLAN PC5, PC2 is member of VLAN 20. That means this interface is in VLAN 20. So let me configure these two access port here. Say interface E0/1 switch port mode access, right? By default mode is by default mode is dynamic auto. So here manually I have configured what access, and now I'm going to say switch port mode, switch port access VLAN. Now you are member of VLAN 10, switch port access VLAN 10, and VLAN 10 does not exist over here. So guys, what I am going to do, I am going to configure VTP on all switches to propagate VLAN information, because if I will configure again VLAN on all access layer switches, I have to set the name, right? I need to configure all VLAN, means I need to run 4 command to configure VLAN, 4 command to configure the name of VLAN, 8 command on one switch, and I have 4 switch. I need to run 24 commands here. So it will be better if I will enable VTP. So go to distribution layer switch 1 and say VTP domain name, domain cisco.com. VTP domain name is cisco.com. You can configure same VTP domain name on all switches, and then I can configure VTP password also for security. VTP password is, let's say, Cisco @ 123, right? Links are already trunk, and VTP mode server, let's say this is my main switch, and I am going to configure all rest switches as, let's say, client or transparent, so that those switches cannot modify the VLAN information, right? Now again let me save this configuration here and go to distribution layer switch 2. On distribution layer switch 2, so VTP status, here you can see VTP mode is server, but domain name is, guys, cisco.com, client, right? So VLAN brief, so we have these all VLAN, and here I have one interface in VLAN 10 and one interface in VLAN 1. So this interface 0/2 should be in VLAN 20. Let me correct it. Interface VLAN, sorry, interface 0/2 is 0/2, say switch port mode access and switch port access VLAN 20, right? Now so VLAN brief, done. Then guys, let me configure distribution layer switch 2. So on distribution layer switch 1, I have configured the access port, I have configured the trunk port. Then on distribution layer switch 2, so interface trunk. So see, with the help of DTP, already these two ports are trunk port, and all VLANs are allowed by default. So let me allow only 4 VLAN. So interface range E0/0 and E0/3. Say switch port trunk allowed VLAN 10, 20, 30 and 40. Then switch port configure VTP domain name, VTP domain name cisco.com, and VTP password is Cisco @123. Done. Now you can verify the VLAN database. So VLAN brief. So we have these all VLAN, but all interfaces are member of, all LAN interfaces are member of VLAN 10 by default. So let me configure the access port. So interface E0/0, and E0/0 is PC3, means PC3 is member of which VLAN. So here you can see PC3 is member of VLAN 20. So say switch port mode access and switch port access VLAN 30, sorry 20. Done. Then guys, go to interface E0/1 and say switch port mode access and switch port access VLAN. Switch port access VLAN means server 1 is member of VLAN 30. All servers are in VLAN 30. So VLAN 30, and native VLAN is still mismatched. So I need to do one more thing here. Interface range E0/0 and E0/3. Here say switch port trunk native VLAN 100. Done. Now exit, and so VLAN brief. So you can see now I have one interface in VLAN 20 and one interface in VLAN 30, means my server is in VLAN 30. And we need to configure port fast as well on access layer switches. So let me do one thing on access layer switch 1. Let me enable port fast as well. So say interface range E0/0 and E0/3, 0/3, sorry. Say spanning tree port fast. Done. Then let me write the access layer switch 1, then go to again access layer switch 2 and use interface range command. Not on this, interface range E 0/0 and 0/3, yes, correct. Switch port, sorry, spanning tree port fast, spanning tree port fast, then exit. Port fast is enabled over here. Now host name is switch 2, and let me write the configuration. Right now go to distribution layer switch 3, sorry, access layer switch 3, and on access layer switch 3, guys, again trunk is already configured. First of all, let me set the VTP password here, that is Cisco @123, and then VTP domain name, which is already cisco.com. Done. Now do so interface trunk. So you can see I have some trunk link, two trunk links are there. Okay, and on the trunk link all VLANs are allowed. So go to interface range E0/0 and E, not 0/0. Let me check again. Switch 3 0/0, yes, 0/0. 0/0 is connected with switch number PC number 5, and 0/2 is connected with this interface. So 0/2 and 0/3. So say 0/2 2 3, and here I am going to say switch port trunk allowed VLAN 10 20 30 and 40. Then switch port trunk native VLAN is VLAN 100. Then go to access port interface E 0/0, and this port is switch port mode access, and switch port spanning tree port fast, and then switch port access VLAN. This port is member of which VLAN, guys? Means PC5 is member of which VLAN? VLAN 10. So let me say VLAN 10. Exit. Then go to interface E 0/1. Again say switch port mode access, and switch port access VLAN. Server 2 is VLAN of part of VLAN 30. So switch port access VLAN 30, and a spanning tree port fast. Done. So access layer switch 3 configuration is also done. Let me do hostname configuration. Say switch 3. Now let me write the configuration and let me show you the VLAN, guys. So VLAN brief. So we have these all VLAN with the help of VTP, and one interface is in VLAN 30 and one interface is in VLAN 10. So I have one user in VLAN 10 and one user in VLAN 30. Then so interface trunk. So we have this interlink is configured as trunk. Encapsulation protocol is .1q, and native VLAN is VLAN 100. So now I need to configure access layer switch 4 finally. So let me take you here, and let me set the host name first. Host name switch 4. Then let me configure the VTP domain name, that is cisco.com. Cisco.com, and VTP password Cisco @123. So I have set the VTP domain name and password. Now interface range E0/ here in 0/2 and 3, means 2 to 3 is connected with distribution layer switch. So switch port trunk allowed VLAN 10 20 30 40. Done. And switch port trunk native VLAN 100. Now I need to configure the access port here. So interface E0/0, which is connected with PC number 7, and PC 7 is part of VLAN 10. So say switch port access VLAN 10. Done. And switch port mode access and a spanning tree port fast. Exit. Then interface is 0/1 switch port mode access switch port access VLAN. PC8 is member of which VLAN? PC8 is member of VLAN 30. Oh, server VLAN 40 is server VLAN. So servers are in VLAN 40. Okay, I will correct it. Switch port access VLAN 30 and a spanning tree port fast. Done. Access layer ports are configured, guys. Now on access layer switch 2 and 3 I have some servers, so let me correct the VLAN. So go to this switch and interface E0/1 switch port access VLAN 40. This interface is part of VLAN 40. Then go to switch number 3, and here also I have one interface, which is interface E0/1 switch port access VLAN 40. Now servers are in VLAN 40. Let me write the configuration. Done. Now guys, there is connectivity between distribution layer and access layer switch. Now I am going to configure RSTP protocol. After that we'll verify that end users are able to get IP address from DHCP server or not. So go to distribution layer switch 1, and now you will not get native VLAN mismatch error. Say a spanning tree mode RPVST and save the configuration. Then go to distribution layer switch 2, enable config t host name, not no host name, spanning tree mode rapid PVST and save the configuration. So for faster convergence I am changing spanning tree protocol. Then go to access layer switch 1 and say spanning tree mode rapid PVST. Done. Exit. Then go to switch access layer switch 2 and say spanning tree mode rapid PVST. Done. Let me save it. Then go to switch number 3, spanning tree mode rapid PVST, and let me save the configuration. And now go to access layer switch 4, config t spanning tree mode rapid PVST, and let me save the configuration. So guys, now I have set up the DHCP, I have configured the switch port, I have configured the VLAN, and I have configured the DTP, I have configured the VTP, RSTP, port fast, right? Now let me verify that end users are able to get IP address from DHCP server or not. Like PC1. PC1 is a part of which VLAN? PC1 is a part of VLAN 10. So PC1 should get IP address from which subnet? From 192.168.1.0/24. So let me say IP DHCP. Yes, DHCP is working. You can see DORA process is completed, and now this machine have got the correct IP address 192.168.1.1/24, and even gateway is also right, which is virtual IP address. Like this, all end devices can get IP address from DHCP server, guys. Okay, for PC2 you can see PC2 is member of VLAN 20, so it will get IP from different subnets. Say IP DHCP from 192.168.2.0, right? Virtual means default gateway IP address is going to be 2.100. So you can see here IP is 2.1 and gateway IP address is 2.100. Okay, so end devices are able to get correct IP address. Now I can configure port fast on these switches, right? So guys, and MAC address table also. So go to access layer switch 1, and here I can say config t MAC address table, and let's say aging time. Aging time is let's say 500 seconds for VLAN 10. So according to your requirement you can set the MAC aging time, right? And let's say for all rest VLAN, MAC aging time is going to be same. or for server VLAN also I'm going to increase the MAC aging time, that is VLAN 40. Okay, for data VLAN, and for VLAN 20, which is my voice VLAN, that is also important. Okay, so I have set MAC aging time 500 seconds for these three VLAN. Do I have any server on this switch? No. So I don't need to configure any static entry over here. Let me save the configuration, right? So MAC address table aging time, here you can see for VLAN 10 MAC aging time is 500 seconds, for VLAN 20, for VLAN 30. For rest all VLAN global aging time is 300 seconds. Now let me save the configuration of switch 1. Now go to switch 1, switch 2 guys, distribution layer switch 2, and on distribution layer switch 2 I am going to set one static entry for the server. So I need MAC address of server. Let me do one thing, let me configure IP on server, say IP DHCP server IP address is 192.168.4.1. Now I can check MAC address of this server on switch number 2. So let me take you to switch 2 and say so MAC address table, right? And guys, see the MAC address on 0/1 interface, because 0/1 is connected with server. So on 0/1 interface, this is MAC address. That means this is the MAC address of my server 1. So I can configure a static entry here, say MAC address table, then MAC address table and address static, after that MAC address. So this is MAC address of server, and after that VLAN. So this server is in VLAN 40, right? After that on which interface? So on interface E0/1. So I have configured this static MAC address on 0/1 interface in VLAN 40. Now I can set the MAC aging time 500 seconds for VLAN 10. MAC address table aging time 500 seconds for VLAN 10, for VLAN 20, and for VLAN 40, right? Save the configuration, and now so MAC address table static. Here you can see you have one static entry that is permanent. So for server you can configure the static entry. Now save the configuration and let me move to switch number 3, distribution switch 3. Again on distribution switch 3 I have one server, that is server 2. So let me say IP DHCP. So it will get IP address. After that it will generate gracious ARP to check duplicate IP address, and then switch 3 can learn MAC address of server. Even switch 3 will learn MAC address of server while forwarding DHCP packet. Okay, so switch 3 MAC address table. So MAC address table on 0/1 interface, guys. Again, switch is learning this MAC address. That means this is the MAC address of server 2. I can configure one static entry here. Say MAC address table static, and then MAC address. After that VLAN. So VLAN is 40 and interface E0/1, right? Then MAC address table aging time 500 seconds for VLAN 10, for VLAN 20, and for VLAN 40. For all rest VLAN, MAC aging time is 300 seconds. Then on switch number 4, let leave everything on default. Means for all VLANs, MAC aging time is 300 seconds, right? So now I have configured the MAC address table. Next thing, I can configure port security here. So go to again access switch 1 and say interface range E0/1 and 0/2. These two are access port where I need to configure port security. Say switch port security. Command is rejected because E0/0 is dynamic port. Sorry, on switch number 1, not 0/0, 0/1. Extremely sorry. Interface range E0/1. You cannot configure port security on trunk link. 0/1 and 0/2. Say switch port security. This command will enable port security. After that I can say switch port security violation. So whatever violation you want to configure, let's say shutdown, so it will shut down the port. Then switch port port security, and you can configure the aging, you can configure MAC address, right? So if you have MAC address, you can define the MAC address, otherwise you can say ST key, so it will learn dynamically. After that, switch port, port security, switch port security, and I have configured the violation. You can configure the maximum number of MAC addresses, allowed MAC address on this interface, right? So let's say maximum is only one, right, or two. Let's suppose one for data VLAN and one for voice VLAN. So I'm going to allow two MAC addresses here, right? Now do so history. I need to paste same command on, guys, switch number 2 also, right? So let me copy the command and let me write the configuration here, right? Then go to switch number 2 and config T. Still I'm getting native VLAN mismatch error. What happened? Interface range is 0/1 to 0/2, 1 and 2. That is correct. Okay. Then switch port security. Okay, switch port security is not allowed. Here port is 0/0 and 0/1. Sorry. So say interface range is 0/0 and is 0/1. Ports are different here, right? Now I can copy these commands from switch 1. Okay, and then I can paste it over here. Done. Now let me write the configuration and go to switch number 3. On switch number 3, say interface range E 0/0 to 1, and now I can paste this command. Say write. On switch number 2 I have write the configuration, then go to switch number 4. On switch number 4 also interfaces are 0/0 and 0/1. Interface range is 0/0 and is 0/1, and let me paste the rest configuration. Done. So I have configured the port security, guys. I have configured the DHCP, I have configured the switch port, VLAN, MAC address table, DTP, VTP, RSTP, port fast. Now we need to enable telnet and SSH on all devices. We need to secure these devices, means we need to configure console password, line VTY password, enable password. I have already configured the default gateway, right? Now I need to configure router and routing between distribution layer and core layer, as well as ASA firewall, right? So video length is getting longer, guys. I will do one thing, I will make part 2 of this video and we'll discuss rest configuration in that video. Okay, so that's all for today. Today we understood some basic configuration only, right, of this topology. I will configure rest thing in next video in part 2. Okay, now if you have learned anything from this video, please hit on like button, guys. As I told you, this is a user demand video, so definitely I am going to make part 2 as well soon. After finishing this video, even I will start configuring. So actually I am dividing it into 2 parts, right? So if this video is helpful for you, please hit on like button, and if you have any question, please let me know in the comment section, guys. And if you want really more videos like this on my YouTube channel, so please type yes in the comment section, guys. Your yes is really motivating me to make more videos. Okay, so yes, if you want more videos like this, please type, please type yes in the comment section. Once you will type yes, I will get to know that you love these types of video and you want more videos like this. Okay, thanks for watching. That's all for today. We'll meet soon in next video.